Hello. So nice to meet you. So nice to be here. My name is Fabian Franz. I'm the VP of Software Engineering at Tech1. For some reason, at some point when we redesigned our website, we used these nice mountains, and now it's finally very, very fitting to present them here. I'm very pleased to today talk about EasySSR, the most simple way to use P-React and Drupal for SSR that no one talks about. This came actually from a project. It has already been a few years back, but it was too good a project for not sharing it. So that's why I'm sharing the research that we did at that point. You can follow along with the slides if you want. You can make a photo of that and then use the QR code to look at the slides yourself. You'll also find the slides there at bit.ly easy-SSR talk. I'm Fabian Franz. Let's see the camera better. I'm the VP of Software Engineering at tech1consultant.com. I'm performance expert and software architect. That means I've architected a lot of things that you're using within Drupal. For example, this thing called service container is still using some code for me, but also the whole caching system was revamped by me and Wim in 2015, and still working a little bit on that. And also I'm a Drupal 7 maintainer. I know it's getting slowly at the end of its lifespan, but it was a fun time so far. And what I really dislike is over complex things. And we had a project where we were working with React and P-React, and essentially we found that nothing was fitting for what we needed, so we built our own. Tech1 is the #2 all-time contributor to Drupal. We have a global team of 100+ experts. Right now, the largest concentration of core contributors at any organization that you can find. And we also contribute a senior full-time infra expert with Drupal Association. So that's what we do. And if anyone's interested, we are almost always hiring. We work with a lot of industry leaders across all sectors. Amazing how we've grown. Here again, the QR code in case you're interested. Okay, just to set some expectations on the scope of the session, one part that I had in the original session description did not make it. The decoupled layout builder. It did not fit. Session was getting too long in the SSR middleware. But what this session is about, it will explain the EasySSR as an architectural approach. It will give the examples for how to get this approach to work. There's also code online with lots of examples. So it should give you the ability to be productive with this. But first, let's start at the very, very beginning. Why SSR in the first place? So SSR in the first place because we want this, or rather avoid this, that it doesn't happen that if we don't have SSR, that Google is like penalizing us so much that there's almost no more page traffic. And that's a pretty recent example from 29th February. Suddenly came on my Twitter and I was like, yay, exactly what I need. So that was pretty good. The impressions here, we have can easily see from 40K we got up to 120K. So yeah, it is important. By server-side rendering, you get a better Google score, a faster user experience, and your pages are CDN cacheable, which is a pretty big deal in that. So you pretty much need that, and you want CDN integration in all of that. But server-side rendering in general is pretty hard. It's gotten a little bit easier now with React 18, But the problem was when we were doing that project, essentially what we did was we were rendering the page once, and all we were seeing on that nice rendered, pre-rendered page was loading placeholders all over the place. So that's not helping, because if Google sees loading, well, it wouldn't index that either. So that's not really what we want. Some typical front-end application code is we have like a context page, context, set context, use state. Not get overwhelmed of that, but that's essentially how a data loader for that is working. So if we check, we have like, we want to load some context, so we need some state for that. Then we need some state for if this is currently loading, so we know in which state we are. And then we need to know even if we are in an error right now, so we need another state. So we're using a callback. We want to set the initial state to it's loading and no error. Then we are awaiting the fetch of this JSON API callback. And finally, when we are done, we are setting the context with some transformation from the context from that JSON API response. And all we need essentially care about is this use effect, because that screws everything up. And I was like, yeah, okay, use effect is running asynchronously. And the problem is, okay, if it's running asynchronously, then we get this loading placeholders. But once this page has been rendered once, there's no one there to set states, run the application, or do whatever. So that won't help. So what we did here, what I then thought about was, okay, I'm really smart. I will just use synchronous calls. And it was so slow, didn't work. Not possible. So essentially we have here our state machine. If it's an error, we show an error. If it's loading, we show loading. And if the contexts are, we show our context list component. Yep, that's saying this again. So again, recap, placeholder is shown where the data is loaded, error is shown if there's an error, and the content list component is shown on success. Sorry. For server-side rendering, you need either code which now runs all these effects and loads the whole React application, which is what render to Piper Stream essentially does, but it's React only, so if you're pre-React, you're out of luck again. Or you need frameworks like Next.js, Gatsby, whatever like that, or EasySSR. So let's take a quick look at frameworks, because we obviously evaluate them. Frameworks solve server-side rendering in the following way. They use a pages/ structure. So essentially the routing is pretty explicit. You can exactly know which pages this application contains, which is great for static generation of that application. And you also have a special property because you have a data retrieval function for each route. So for example, if you use a /context, then it routes to /pages, context tsx, then it calls this getStaticProps function in pages context tsx that gets called before the server-side rendering is running, and then the page is rendered with the props already loaded. So this looks in practice like that. We have this getStaticProps function, and then we have like a menu and context we need to load, and then we are calling here some kind of repository factory to load all of that. It works, but it always means I need to know what things I have on a page. And within Drupal, what we like to do is we sometimes like to use things deep within, like have a little block here, have something there. Even with layout builder, think about it, like you have some decoupled blocks within in a layout. That wouldn't work. You wouldn't know all data in advance. So that's a little bit problematic, but it obviously works. The other thing is with Next.js, it gets pretty complex pretty fast, because what you want is this getStaticProps, but then you are locked into the incremental static regeneration, and incremental static regeneration means that you need a preview mechanism, which is per URL, and that means it's not compatible with workspaces. And then you also have a need for invalidation, and that can't use cache tags. So it's all a little bit it feels a little bit outdated in terms of how we normally think of it from a Drupal perspective in terms of caching. Good server-side perhaps, on the other hand, is an API call that is never seen by the client. So in general, that does what we want. But the problem is now we have no more interactivity at all on the client because everything is server-side. Not really. Get client-side props is this poor client-side API call that we've seen before. So that one could work. But now we have the problem again. We don't know the data which it will need before it's called. So just to take a look at these 3 functions again, get static props, and then we have the page. So here you can see the props are returned and then the props are given to the page. So this is how this works. And next there's some kind of magic of like compiling this and then exporting this get static props and then calling it first and then include it into the routing mechanism so that finally they can call the page with the data already there. Get server-side props looks very, very similar. In fact, it's almost the same, but it's really just that this is happening completely server-side. And here this page is, even if this is called on a client side, it wouldn't get these properties. It would just return the HTML always. Client-side data fetching finally uses a very similar pattern that we've already seen. Maybe the Next.js example is a little bit easier to understand. But again, we have this use effect and we have this kind of like state machine again in terms of how it works. If it's loading, if there's no data, if return. So which way to go was the question at that point for us. Client-side is usually what we want for simplicity because it's easy. We can just, wherever we can build our pages, we have a component, and then we just load our data from JSON API and everything would work. And it worked us. I mean, if I use a simple only client-side application, everything works out of the box. Server-side, that approach is what we want for server-side rendering because we really want the props to be as simple as possible to render HTML. And the static part is what we want for caching. But the problem is that this invalidation Next.js is so outdated. So no approach did really make us truly happy for that project. We want them all. So one thing what's always good is if you're at such a problem is to think about what do you want to do? Do you want to use like client side? What does we want them all actually mean? So we want the basic structure of the client side for simplicity. Then we use the EasySSR approach for the server side, and caching is done completely in Drupal. So we vastly simplify our infrastructure of how this is usually done. I don't need to set up all these servers, etc. So the goal is that we have as little difference between server side and client side as possible. So you can write a client side application, add the EasySSR approach, and we'll see how that works. Couple up with Drupal, and it will all come together. You can, however, still do essentially this little check, which means, am I running on the server? If there's no window, I'm running on the server, essentially. So let's talk about the architecture. We have a user, and the user wants to look at our contacts page, like who they can contact in our company. So we have a front-end theme, and this front-end theme essentially is just returning the HTML of the front-end application. Then we have the SPA admin module, and this shows the admin bar on top of the front-end application. So the application now feels integrated into Drupal, but we have no server-side rendering yet. I'm just going to quickly show this of how this looks in the configuration, just to get an idea. So we have this SPA admin helper, and we route everything to this EasySSR app theme. And essentially, we define here the paths that whenever we have this URL pattern, which is everything, then we'll use the React local provider. We won't do it for login, reset, or logout. And then it means we will, without any changes, we'll always go to the EasySSR app theme. And this EasySSR app theme looks like this. It's very, very simple. It's just the info. So we have, it's a very, very easy theme, and it just depends on the SPA admin as base theme. Right now it has a core version requirement of 9 because this wasn't updated yet, but it should be possible to update to 10 with some changes. The libraries are, it also uses some admin libraries, which are defined here. And yeah, it's essentially nothing more is needed like that. And then we have the second part, which is the version. And here we define that we want for our admin facing things, we want some overrides and we want some special admin CSS, which just allows us to ensure that our theme looks a little bit nicer within Drupal, because our front-end theme could be conflicting with the markup that Drupal already has. Yeah. And the second part is we define how our app ID is. In both React and pre-React, you can define a root of the application. So what you don't want is you want your React application not be mounted to the body root, but you want it to be mounted to the special app ID. And then you just define the app path, which is /app EasySSR app, and that's it. And there you then define your application. So that's how it works in general. So let's go back to the slideshow. Okay, so this is in general how it works. So now we have this Drupal integration, which was one outcome of that. And SPA admin is maybe even a little bit misnamed, because it's not only for single page applications, but for general decoupled things. And it's not only for admin, as we'll see in a moment. Because the general way how the page request architecture now works is the following. We're getting the context from Drupal, and the page cache works like normally. Drupal is then connecting EasySSR and Node service, which is server-side rendering this context page. And then the server-side rendering contact page service is again calling Drupal with the JSON API things, etc. And so this EasySSR part is as simple as possible. It could even be serverless because it's only called on demand. So in theory, you just need to call a process which gets a URL, which is then server-side rendered, and there's nothing more you need to think about. So this is, again, it's a very, very Drupal approach to front end in that, which was the goal. The page response architecture works as following. You are getting returned the HTML for the rendered page, and you get the minimal JSON included in HTML for hydrating purposes. That means the page is loaded with 0 AJAX requests. And this is important, because what normally happens, and I've not checked how React does it in version 18, if they do some magic or not, is you have this nicely hydrated page, and now it loads for the user. And now the first thing it does, it makes an AJAX request. And then when that AJAX request comes back, just then the application essentially gets interactive. Before it's not interactive. So you essentially want to have the state that was used to create that page to be on the page as well. On the client, this looks, yeah, and that was essentially what I was explaining here. In a way, what we have is this minimal JSONs included in the HTML for hydrating purposes, and this is a cache. And now we are talking my language, which is caching. And so we've changed the problem from this is a server-side rendering problem in Node to a problem of this is a caching problem. And now everything got a little bit easier. Because from the SSR problem, we still had this loading problem. Because we could render the page and we get all these loading placeholders. But if we knew these URLs in advance, then we could load them up front. But again, we have this chicken egg problem because we don't know them in advance. So back to pages, no, there's a better way. So let's assume for a moment that we had the data already, that we knew what URLs that page would need to load. Like it would need to load that blog, it would need to load that node, it would need to load that layout builder, it would need to load that contact form, whatever. So what we would need to do to be able to influence this process is we would need to hook into the process of the fetch. And we need to return the data that we have cached. So what we want to do is we create a nice use data loader. And now please don't be overwhelmed. This is essentially just what we have seen before in very abstract in a very abstract state. So that you don't need that. But essentially for our context page, all the complex code that we had before, we can just change to this use data loader. So we have our state machine here. We use the data loader and everything gets very, very simple. And here we have again our transform step. It's important to note the transform step because the transform step is actually retrieving the data from the JSON API response and then making it possible to have the minimal data like the name, the image of the persons in that concept. So that's the power of React hooks. Kind of funny that we need to hook into it, and the hook allows us to do so. So what we then do is we create essentially a decorator, and we create a use cache data loader. And then this use cache data loader, we use a very, very familiar pattern again. We are having a resolve cache miss function, which is given as a callback to the page cache. And we have a cache ID, which is essentially just a URI. And then we have a transform function, which ensures that if there's a transform function, what we store in the page cache is not the raw JSON API responses, which can get really, 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 really large, but the already transformed data. So the data used for the rehydration of the page is again minimal. To be fair, Next, etc. also allows this because what you usually do in the get static props is you also reduce it to the bare minimum so that this works. So with the cache data loader, what we can now do is we can retrieve the contents of a URL from the cache page state. Now we use the transform function to store this minimal data, and then we can return the data that we have cached, or if we don't have it, we just call the normal use data loader. So let's look at a quick before after. That's our context page before, after, before, after, before, after, before, after. So the only thing essentially that changes is that we move this little get context from response up to here and give that as a transform callback, and nothing else changes. So and that we use a cache data loader now. And the nice thing about explicitly going into that this is cached now is that essentially now we are determining, okay, this can be cached on the server as well, but we don't need to use a different function like get static props or whatever. We just add a little decorator and we're done. So to recap the whole thing again, we are hooking into the data loading process. We do a cache ID to data mapping, and we ensure the data is transformed after retrieval. Here in that URL lines, that is my GitHub, you can have the EasySSR talk, has a README, it has a page cache, and also all code examples that you see here. And that's the one that does the magic, the page cache, so you don't need to deal with that. So what is a page cache about? The page cache has, first of all, provides a page cache context, which is wrapping the whole application. Then you have use page cache and use cache plugin as hooks. And there's 4 different plugins. The null cache, so if you don't set up a bin, it will be used in null cache by default. It's essentially a no-op. You can use the static cache, which is just caching things into this static page cache context. You can use the read-only cache, which is mostly used for retrieving from the embedded JSON for hydrating purposes. And then we have the fetch cache. Fetch cache? What's that? The fetch cache is where all the magic comes, because the fetch cache allows us to cache all the contents of the URLs in the fetch cache during server-side rendering. So what we're doing is we are rendering this page once, we're collecting all the URLs, which we now know, then we're retrieving all those URLs and the data, all in parallel from JSON API. So the slowest time this page will render is the slowest request, essentially, from the whole JSON APIs. So that's all in parallel. And then we SSR the page again, and now we have our URLs. And with that, we have our problem solved. And the reason this works at all is because a P-React page, for example, takes only 12 milliseconds to render with the loading placeholders. So that is compared to, unfortunately, how usually JSON API is. We could render the page 10 times and no one would blink an eye in terms of how much speed we gain or lose in that. In this case, and it's afterwards cached in CDN and Drupal page cache anyway. So the difference between 12 milliseconds and 24 milliseconds is absolutely neglectable. So, and a front-end application will also not cascade fetches more than 3 to 5 levels deep, because else you would get a very, very hefty penalty from Google, which would like say, well, you load a node, then you load a block in it, then you load another block, then you load another block. It would take forever for that thing to load because you would add up all those times. So front-end applications are typically not done that way. And that is why, and that is the practical assumption that we can make, which makes the whole approach of rendering things twice work. And because we use these cacheable data loaders, it's a deterministic outcome. Little nesting, and yes, we got it. It definitely works. So, and that is how we have solved the chicken egg problem of essentially not knowing the URLs before rendering the page, and then, but needing to know the URLs to avoid this loading placeholders. We just ran it twice. So the fetch data loader again is very simple. We just use page cache again with another bin. It's very nice to implement Drupal concepts in React. Makes things very simple and clean. So we just use URI, and then we have as a miscallback, we just use the uncached data loader like usual. And we only want to use this page cache when we are on the server. So if we are on the client, the fetch cache isn't even used here for that, because we have the page cache for that. So, and then we can see how a typical application would look like. There's unfortunately still a lot too much boilerplate, and I presume with a little bit more magic, this could probably be reduced to something which is just providing a page cache provider wrapper or even component, which is then including the app. But right now it is so much boilerplate, it's what it is. This is essentially creating a signal before signals existed, because it uses a counter which is added here, which ensures that whenever something changes in the page cache, but it's deep within, we won't replace this property all the time, but it changes within this property, so React wouldn't know it changes. For that we use this kind of counter, signal cache counter, and that part. So the cache plugin essentially has 3 properties. It has a page, a plugin class, the pre-render data, which is the initial state of the cache, and then a callback that's always called when something changes inside. So when someone uses cache set, essentially. So, and here we have the cache state can be directly accessed via the cache plugins.state property. So the use cache plugin ensures this property exists. And now this makes it very simple because now we have our pre-render data here. And what happens with this page cache provider is we automatically generate the script type text PD. And this page cache state is always shown in that div. So while this page is being rendered, we are creating this, this page cache not only within a state function, but also as raw HTML directly, which was a pretty hard problem to solve because the problem I had with Preact again was, and React in a similar way, was that I needed to know the data for the server-side rendering to be included before it was running. That was not what I wanted. I want to have essentially a mirror of the state that this application was using for initialization to be directly on the page so that I can do the hydration from there. And this is how it works. So, and here we see essentially how we load the data. Just use the read-only cache plugin when we are on the client. Getting this element, parsing the JSON, pretty standard. And the pre-render data, again, we if we use this read-only cache plugin, then it's not updated anymore. So there's essentially a snapshot of the data of how it was on the server when it was rendered. Here's just a component of how it looks. Again, this could probably get into the EasySSR directly because it's always the same. And now we also need the fetch plugin for server-side rendering. Again, it's very simple. We have our application. We just define another cache plugin, which is the fetch plugin. And here we give two things from the CLI data. And CLI data is now a little bit Preact specific, but React has something similar. Essentially where we know that we can give a store and a callback so that we can render that page and then we have the state of that cache after the rendering. It's not lost somewhere. And that's how we finally get to rendering content. We're getting we are setting up this fetch store, the fetch callback, we render the whole thing, and then we go for each cache ID in the fetch store, we return the URLs, we set the new fetch store, we pre-render it again, and that's it. And that is essentially what is used in both the pre-render JS and in the server-side rendering JS. Yeah. So is it fetch store versus page cache? No, it's both, because the fetch store deals with a raw URL not fetch, and this is only for server-side rendering purposes. This is storing the raw JSON API responses. So if you were using only fetch, then the client-side page would load and would immediately do the JSON API calls to start to hydrate. But if we are returning the transformed data, then we avoid this XHR request on hydration, and we know so we need both the fetch store and the page cache. And that's even nicer if you combine that now with for example, web workers and generation of a static application like Preact can do. Then you even have always static HTML, and you essentially have never any request to the server at all, and your page, your application is still fully interactive, which is very, very nice. So Outlook, is it easy yet? No, definitely not. But there's huge potential, and the potential was so huge that I decided to share the approach. In general, the approach is three parts. You're using this cache data loader as a simple wrapper for data retrieval. You are automatically generating this pre-render data during the page generation, and then you are automatic fetching the URLs during the SSR process. And is the Drupal integration easy? No, not yet either, but there's also a huge potential. If you use the SPA admin module, which at some point will probably be renamed, then you can have React everywhere. You have your Drupal admin bar, you have your React application, contextual links are working. With a little tricky. You can even get Layout Builder to run. You have the ability to essentially use this like that. You can pre-render this application very similar to it works with Gatsby, using your own rules and own things. And essentially, let's assume you've spent a lot of money, a lot of time to creating this client-side application, and suddenly someone comes and says, now I need it statically generated. This is possible with that. The last part is to connecting a Drupal middleware. Essentially, it's just a middleware that's just an API call, like a request call to Node. In worst case, if it's not available, okay, and there's no SSR available right now. And if you want to be as cool as Next.js incremental static regeneration, you can always use a page cache boost module, both for normal Drupal sites as well as decoupled sites with that approach, because it allows you to very simply, essentially what happens is you get a page cache expiration, and then you get someone retrieving it, and then they get an outdated version. Yes, outdated data. Meanwhile, that page is regenerated in the background, and then the next visitor gets a newly nice, shiny version again. So this is, again, standard Drupal architecture, but obviously also works in combination with this SSR approach. Here, just the SSR would then be done in the background. So, yep, that's it. With that, you can explore EasySSR as a new approach. I'm still a few days here, so I will probably see if I can get to hacking on that a little bit more. And we'll see how time is. But here's again the link to the talk slides. And that's it. Do you have any questions?
Yeah, I'm curious. I mean, you looked into Next.js when the pages directory was.
I'm having trouble.
Okay.
But now, I mean, since Next 13, there is the new app directory. I don't know, have you heard of it and all the new innovations around server-side components in React?
Yes, I definitely have heard about it, but I still feel they're overcomplicating things. Because at least from my Drupal perspective, what I want is a Drupal system with a Drupal router, with everything as Drupal-y as possible, but I want the nice React components, I want the nice front end, I want the nice things, but I do not, for this specific use case, I do not want to deal with all the overhead of frameworks, of things, of setting up extra servers, etc. It's really for the person that wants Drupal and wants to have the nice interactivity, the nice things, but still also wants a server-side rendering. So that is essentially the approach here.
I mean, I very like this approach, and I would love to have a standard solution for these kinds of setups with Drupal only. My only concern is that the industry is heading towards somewhere else, like Next, whatever, all these fancy frameworks. And but yeah, I mean, go on with that, and it looks very promising. Yeah, it's cool.
The point to the industry is going somewhere. I've just recently read about tweets of someone giving up on Next and things like that, and was like, why did I ever switch from Rails in that? So while it is a nice thing to always search for the nice shiny thing and the next thing in that, the problem with that is you almost need a diploma for understanding these front-end things, and I never liked that. And with Preact and especially, and maybe I can get it to run, you don't even need a compile step if you don't want to. You can even run, I mean, for server-side rendering you then would, but you can run it in combination with HTML, and then you can run it without, I mean, you can run it like jQuery. Like you write your component, you reload the page, and it's there. It's like nothing needs to run in the background, nothing needs to monitor. And I think it's right time to simplify the whole thing. And what Drupal earlier stand for was innovation in doing its own thing. There was not always the right thing in that, because sometimes we were a little bit too much on our island. But on the other hand, that island has also treated us very, very well in many cases. And I think the mistake Drupal at that point in past time has made is it innovated, but it never shared it with the world. So others came and then were using it. But with PHP, for example, Drupal had been influential in improving the caching spec of PHP in that. So, and I think one needs to start somewhere. So that would be my idea of that.
Hey, thanks for the presentation. I probably missed it, but can you rule out some blocks? For example, if you have a logged in user, you say hello, logged in user, username Arto. So can you rule that out from the pre-rendered, like server-rendered page?
You're not talking about having the user log in into the application.
Yeah, I mean that if there's something that's user specific, for example, or specific for something that you don't want to show, but you would like to have the other parts pre-rendered.
That's a nice thing about this approach. Obviously you can always define. The thing is, usually you don't need server-side rendering for something that is logged in users, because you really only need it for page scores, for crawlers, etc. You might want it for user speed of getting them a nice experience in that, or statically pre-render an application in that, but usually not for authenticate users. But if you had, obviously you could always use your switches. You could, in Drupal, it would be as easy as setting up a page context on that page, essentially. And then you just add, if there's a user page context, like logged in user, you just add a question mark user equals UID to it. And then you have a different URL to which it goes. And then you have two server-side rendered versions. So again, this would be no problem with that approach.
All right, thank you.
Seems like we have no more questions right now. Then we can just look at the pre-React package JSON config. Essentially what I did for this application was three things. There's a normal build, which is no pre-rendering at all. Then there's a production build, which is going into the build prod directory. It's not using inline CSS, and it's using this special pre-render URLs.js, and it's using a special template. And then there's a normal node pre-render JS. And these are all the possibilities on how you can now hook up Drupal with that part. What pre-render URLs.js essentially does is it needs a list of all pages that need to be pre-rendered. And again, because we set it up with Drupal, what we do is we ask Drupal for the pages that exist in that. So the nicer thing about this approach is essentially you create a page in Drupal and now it appears in the front-end application. So that's essentially also the goal. So really React is here used as a presentation layer. So that is probably one of the most important things. So you have the whole presentation layer, you have your client-side application, and then as last step, you just add a service for server-side rendering, and then it all works. Okay, if there's no more questions, then thank you so much. Have a wonderful Drupal Mountain Camp, and I see you all around.